Okay, in this video we're going to try naming ionic compounds and writing the formula for ionic compounds. Alright, so let's start out with type 1 ionic compounds. Alright, let's see if I can spell compounds correctly. Okay, so type 1, we have here in all ionic compounds you have a metal plus a non-metal. So let me come up with one here. Metal. Let's do silver. So Ag, and it's going to be combined with oxygen, and so it's Ag2O. We have to name this. So it's type 1, meaning silver always has Ag plus 1, and oxygen, of course, is always -2. So we crisscross the charges, and that's how we got Ag2O. So to name it, it's type 1. Silver's always going to be plus 1, so we just say silver, and then oxygen, you change the ending, so it's oxide. Alright, this is just review. You've gone over these before. Another type 1, magnesium, and I'll pick a different anion. Let's do fluorine, and so it's MgF2. So magnesium fluoride is always MgF2. To name it, you name the first element, which is your metal, magnesium, and then you name the fluorine, becomes fluoride. Because magnesium is always Mg plus 2, and of course fluorine or fluoride is always -1. So again, magnesium always has a plus 2. It's in group 2, always plus 2. Silver is one that's on your ion sheet. You just have to know silver is always plus 1. Another one we could do would be Li3P. So you look at this compound here. Li is lithium, so we just name it lithium. It's a metal. Since it's a metal, we're not going to use prefixes. So we look here. Phosphorus has a -3, so that's why we have a 3 there. So we just name the second one phosphide. P is phosphorus, becomes phosphide. We change the phosphorus ending to "ide" because it's an anion. So those are simple. I kind of quickly went through those because you know that lithium is always plus 1, silver is always plus 1, magnesium is always plus 2. So that's how we name them. We just name the first element by its name. The second element, we change the ending to "ide" on all of these. Okay, that's type 1. Now, type 2. On type 2, we don't know the charge of the metal always. So let's do Fe. It's going to go with nitrogen, and there. We have Fe3N2. So to name this, we can't just say iron nitride like before. We have to add something to it because this is a type 2. Iron, if you look on your ion sheet, can be Fe plus 2 or it can be Fe plus 3, so it's different. Back here with the type 1, lithium was always plus 1, silver is always plus 1, magnesium is always plus 2, but iron, hey, he can be plus 2 or he can be plus 3, and so we have to look at our formula here to come up with what it actually is. Nitrogen, nitride I should say, is always -3. So to balance out, to look at this, we say we have 3 irons and to every 2 nitrogen. So we can just crisscross the subscripts back to what the charges are. So nitrogen has a -3, and that's why there's a 3 there for the iron. Iron then, therefore, must have been 2 because it has a subscript of 2 after the nitrogen. It would take 2 nitrogens with a -3 to balance out 3 irons with a plus 2. So there's 3 of these guys to every 2 of these guys. 2 times 3 is a positive 6. 2 times a negative 3 is a negative 6. Positive 6, negative 3 balance out to 0. That's what we want in our type 2 or type 1 ionic compounds. So this is iron 2. That's what we say. So iron 2. Now you can look on your ion sheet and also call it ferrous, I believe is the name, ferrous nitride. I prefer and I think it's easier for you to just name it this way, iron 2. The 2 corresponds to what charge it has. Alright, so that's type 2. You have to include the Roman numerals. Let's do one more. We could have, let me look here, another one. Let me think of it. Okay. CO, and we're going to put that with oxygen. So we have cobalt, so we just write the name, cobalt. And then we have oxygen. It's the second element, so we have to say oxide. Now, here's the tricky part. Cobalt can be CO plus 2, and I believe it can also be CO plus 1. But here, I know the charge because oxygen is negative 2, and there's only 1 cobalt for every 1 of the negative 2 oxygen. So to balance this out, cobalt would have to have a plus 2. So, since it's a plus 2, I figured that out from the formula, I have to write a 2. Cobalt 2 oxide. That's type 2 naming. To come up with the formulas, so if I say, let me see here, the formulas are a little easier. Let's say I had calcium oxide. There's no Roman numeral, so I just write down, I know calcium is always plus 2. Always. So that's why there wasn't a Roman numeral there. So I just write Ca. Oxide is always negative 2. So it's only going to take 1 oxygen to balance out the 1 positive, or the 1 calcium with a positive 2. So I just write CaO. No subscripts. Another one we could do would be, let me look here. Potassium. Potassium nitride. Look, potassium's plus 1, nitride is negative 3. We crisscross the charges, so we get K3N, potassium nitride. Then we can switch to a type 2. Let's do copper and who else? Let's put copper with oxygen. So copper oxide. Alright, so we're just going to write Cu. We know oxide is O. I messed up. Copper 1 oxide. I have to include the Roman numeral there to tell you. So since copper is plus 1, oxygen is negative 2. The 2 is just going to crisscross, and you have Cu2O. Alright, that's a type 2 because we have the Roman numeral. These up top are type 1s. Alright, and I can do some polyatomic naming in the next video.